right, so we're going to talk about the discriminant. And the discriminant is just a little portion of the quadratic formula. And it's actually the portion that's under the square root, but we don't even do the square root for it. So what's under the square root?
B squared minus 4ac.
That's right. Good job. So b squared minus 4ac, that's what's under the radical. Now, why do you think this might be important?
Because you could change it.
What happens with radicals? You should have encountered some various things that happened last night with your homework. You could have negatives under there, right? What happens if you get negatives under the radical? It's imaginary numbers. So if what I can do is this allows me to look at just what's under the radical and determine what type of solutions I'm going to have, okay? So if b squared minus 4ac is negative, Mary says you're going to get imaginary solutions, and she's absolutely right. You would have two imaginary solutions. Now tell me graphically what that looks like. It doesn't cross the x-axis, exactly. It may look like, well, it may look like this, or maybe like this. It can cross y, just not x, right? It's never going to cross. It's two imaginary solutions. What other scenario can you think of that may tell you about the solutions when you're talking about under the radical? If it's not negative, okay, 0. It could be 0. If that is 0 under the radical, what does that mean? Why 1? Think about the you're absolutely right. Think about the quadratic formula. I got opposite b plus minus square root of b squared minus 4c all over 2a, right? But I'm adding and subtracting that radical. Well, if that radical's 0, the only thing it leaves me with is the negative b over 2a, right? My two solutions come from adding the radical and subtracting the radical. But if I'm adding and subtracting 0, it's the same thing. So it just gives me one solution. So you're exactly right. That would be when the vertex sits on the x-axis. And then what's the only other scenario left? If you're not negative and you're not 0, that leaves you to only be positive. And positive is the one we're most familiar with, and that is when we have two real solutions, which means that parabola is crossing that x-axis in two places.
That's all I think about every time it goes off.
Look at an example. Golly.
We still have
Okay, it still has to equal 0. Okay, that's still crucial that it equals 0. I don't want to know what the answers are, but I want you to look at this and tell me what type of solutions does this quadratic have?
Stop.
Thank you.
Right.
The directions will say find the value of the discriminant for the quadratic equation and describe the number and type of roots for that equation. Okay? So first off, what's the discriminant? So you say it's positive and you're, I don't know because I haven't done it. B squared minus 4ac, right? B squared would be 121 minus 4 times 7 times 5. So 121 minus 140. What does that tell me about the quadratic?
It's imaginary.
How many?
28 times 5.
2 imaginary. 20 times 7. 4 times 5 I did together, and then I'm going to put this in.
Repeat minus 19.
121 minus...
Oh, I'm sorry.
Oh, I thought you were saying that was...
Oh my goodness, I can't even spell.
Just say man.
We're just going to put a little period there and abbreviate. Imag. Good
I
job.
already wrote that on it for you.
Since I can't spell imaginary clearly. Okay, I put like I-M-A-G-A-N-I. I got my I and A mixed up after that. Yeah, I don't know. Anyway, it doesn't matter. It's imaginary. We can say it. We don't have to spell it. Just put I-M-A-G. That's a terrible thing for a teacher to say. I'm sorry. Okay, so when we talk about two imaginary, I really do know how to spell it. I'll spell it here and make sure y'all know. Imaginary.
We're on video.
Yeah, I forgot I was recording. I better make sure that everyone knows I was just joking. I take responsibility for today. This is my fault. All right, two imaginary, which means it's never crossing the x-axis. That means maybe it's doing something like this because the leading coefficient is I don't know. I don't know what it's going to look like exactly graph. That's not the point of the problem. Huh? Because whenever I did the discriminant, I got a negative number here.
Wait, why can't you just go down?
Because A is positive.
What do you find from the answer of?
Huh?
What do you find like when you solve it? What do you find?
So I wasn't asked for the solutions. I was just asked for the discriminant and the type of solutions. So the discriminant is negative 19. The type of solutions would be two imaginary.
So the discriminant is the answer from b squared.
B squared minus 4ac, yep. Just the part under the radical. Let's do another, one more. Uno más. X squared 22x minus 121. I would. That's what I would do. Do you notice something about the equation? Yeah, you did.
It's a perfect square.
Good job. I told you you'll start to recognize them.
11x times 2 is 2x.
That's right.
So it is.
But if I find the discriminant,
Why? Look right on my face.
what's 22 squared? I'm assuming it's 484.
It is.
Because a perfect square trinomial is only going to have one solution. Why? Ooh, do you know?
Zero.
Okay, so all of them are to 0 though, but think about perfect square trinomial. What happens with the factors? The two factors are the same, right? If I factored this, it'd be x plus 11, x plus 11. So if I actually solved this out algebraically, it only crossed one time at negative 11, right? Every perfect square trinomial that's equal to 0 only has one solution, and that's why. Your factors are the same. One real solution. That's right, Dayton. It only crosses once. Good job. 0 is the discriminant. The discriminant is 0. It has a value of 0. I was just kind of coming full circle with it. I want you to make these connections with it. That's the perfect square trinomial. Yes, it only has one solution because the factors are the same when you solve it algebraically. Tell me what you think about discriminant.
I like that.
It's easy, yeah.